What's up, guys? You ever seen one of these before? It is a December 1988 edition of National Geographic. Alright. I'd like to crack it open to page 911. Just so happens to be the page number. Alright, take a look at that. All these different map names. Azimuthal equal area. Orthographic. Globe. Rosette. Polyconic. Sinusoidal. Azimuthal equidistant. Says it. Robinson. Azimuthal equal area. Mnemonic. A dodecahedron. Interrupted geode. Look at all these maps. Vander Grinton. Miller cylindrical. Perspective. Interesting. I can get it so you can read along. New perspective on the world. Perspective. Not globe. That's called perspective. That's the new perspective on the world right there. Get it? See what they're doing? Alright, let's read it. With the map supplement in this issue, the Society passes another important milestone in its map-making history. For the first time since 1943, we are offering members a different and more realistic view of the world. More realistic? Globes, though often impractical and sometimes expensive, provide the only accurate portrayal of the world. However, we cannot see the whole Earth at one time on globes, nor can we measure distances easily. Maps on flat paper provide a convenient solution, but all, including our old standby, first published in 1922 on the Vander Grinton projection, distorted the round Earth in some way. Our most recent search for a better way to project the globe onto a flat sheet began shortly after I arrived at the Society in 1982. The Society. What is the Society? Many new map projections have come along since 1922. The Society's 100th birthday gave the incentive to search for a new projection for our 1988 political map of the world. In December 1987, a panel of cartographers was appointed to evaluate world map projections. After reviewing more than 20 projections, it was unanimously agreed that one devised in 1963 by the eminent cartographer Arthur H. Robinson of the University of Wisconsin at Madison would serve us and you best. The staff and the board of trustees concurred. I want to mention the map, the flat Earth map, the one, what is it called? We'll just call it the AE map that everyone's talking about, that Jake is having an issue with, and everybody's having problems with, supposedly, is not even that. I mean, look at that. That does not look like the other. So what's going on here? In December 1987, or no, yeah. Oh yeah, okay, so. Aside from many merits of Robinson's projection, I was pleased with the decision for a personal reason. For a personal reason, John B. Garver, Jr., chief cartographer, was opposed to Robinson's projection for a personal reason. When I was a graduate student in the 1960s, Arthur Robinson had opened my eyes to the importance of map projections. Robinson conveyed... Let me adjust that. Robinson conveyed an irresponsible enthusiasm for maps, and he still does. As he told me recently, I've always studied map projections for serious reasons and sometimes just for fun. Recognized as the Dean of American University Cartographers, Robinson began his influential career during World War II, when he directed the map division in the Office of Strategic Services. His idea of a new projection for a world map sprang directly from work on geography textbook in the late 1950s, but he says the seeds were sowed during the war. More often than not, in those days, world maps were drawn on Mercator projections. On the Mercator projection, which Robinson admits having been awfully sick of. Years earlier, at the end of World War I, editor Gilbert H. Grosvenor had also been irked by the Mercator. He called it atrocious for a world reference map. On November 14, 1918, only 3 days after the armistice with Germany was signed, he asked Chief Cartographer Albert H. Bumstead to produce a less distorted world map to show new boundaries and the new countries that would be born after the war. The result 4 years later was based on a projection patented in 1904 by Alphonse van der Grinten of Chicago. Since then, 10 of the societies, capitalized, 13 world political maps have used the van der Grinten projection. How to stretch the round Earth onto flat paper has challenged mapmakers for centuries. More than 100 world map projections have been invented for drawing a spherical network of coordinates and points on a piece of flat paper. A section of 18 are shown on the previous pages. Map projections come in almost every imaginable shape, including a rectangle, circle, ellipse, star, heart, even the form of a butterfly. Each projection has distinct characteristics, and many provide different, sometimes bizarre, views of the world. All projections cause distortion because the skin of a round ball simply will not lie flat. All deform the shapes of continents. Some projections enlarge or shrink them. Some interrupt the oceans, slicing them into unrecognizable patterns in an effort to map the land masses better. All skew distances of directions between places. In choosing a world map projection, there is no single solution. It is simply a matter of finding one that best suits the purpose of the map. Something I thought about last night, because I had read this before, and I actually made this video already. I'm doing it again, hopefully a little better than I did the first time. How do they measure distance? In the air, if there's wind, then all the air is moving. And if the wind's blowing against you, how do you know that you're not just going faster? Because you have to go faster, but your airspeed is what you feel against the relative air that you're passing by. But how can you know where you are if you're, especially if you're flying over ocean, or if you're taking a ship over ocean? Because all the water is also moving. Sometimes the surface water is all moving a certain way, and the boat's going in against that. But say it's coming this way, and it could count, 100 miles across a 50-mile distance if the water was moving the opposite direction of the boat at the same speed. It would seem that it crossed over 100 miles of ocean. Do you see what I'm saying? So in such the large distance between places, without satellites, which we're now not so sure exist, there's no real way to measure unless you can come up high enough and look, and then you can kind of go off the angles, sine, cosine, to find out the distance, assuming you know your elevation. But how do you even know with complete accuracy your elevation, because you're counting the air that you pass, but it's of different densities and stuff? How can we be so sure we know these distances? So I'm just throwing that out there. Let's keep reading. Such an approach led the Flemish geographer Gerardus Mercator in 1569 to introduce a projection gear to navigation on the high seas during the great period of world exploration. Any straight line on Mercator's map of the world is a line of constant true bearing, enabling mariners to plot a straight line course between any 2 points. A boon to navigation, the Mercator is unacceptable for a world reference map, as editor Grosvenor made plain years ago. The projection distorts large shapes and greatly exaggerates the size of land masses in the high latitudes. Greenland, for example, appears much larger than South America, although in fact it is only an eighth the size, roughly as large as Mexico. Alaska and Brazil look equal, but in reality, Brazil is nearly 6 times the size of Alaska. Doesn't that sound like a quote from a movie? This is 1988. I'm not sure when that movie came out, but I'm pretty darn sure it was after 1988, and it's as if they were reading right out of this. At the other extreme are equal area map projections, such as the one produced by the German mathematician Carl B. Mollweed in 1805. These projections depict all regions of the Earth in correct relative size. So the equal area map projection is the one that most resembles the flat Earth map right here. Isn't that interesting? Okay, they're saying that's the most accurate. Okay, and that's straight out of the mouth of the society. These projections depict all regions of the Earth in correct relative size. They are useful in displaying and comparing certain kinds of information, such as the distribution of populations or religions, especially in the temperate and equatorial latitudes. But most uninterrupted equal area maps compress, elongate, or warp land in the higher latitudes and cause shearing and stretching along the outer meridians. For this reason, an equal area projection such as the elliptical Mollweed is not the best for a reference map of the entire world. And that's this guy. For its world maps, the Society has always preferred an uninterrupted projection that displays features on the Earth and their relationships to one another as accurately and with as little distortion as possible. The trusty van der Grinten projection was chosen as a good compromise. In the high latitude, it avoids the extreme exaggeration of area of the Mercator and the extreme compressing and shearing of the Mollweed. Arthur Robinson's projection is better still. In the combination of shape and area, it matches reality more closely than its venerable predecessor, whereas the van der Grinten shows the Soviet Union and Canada at more than twice their relative size. The Robinson reduces the discrepancy to 1.5 times. And although Greenland appears somewhat compressed on the Robinson, the exaggeration is considerably less. The projection does not espouse any special point of view, and we believe that its compromises are the most reasonable for a general reference map of the world. They agree. They believe. Faith. See, they don't know. See, science is the best speculation they can come up with so far. Or is it? I have some speculation that's not even mentioned, and it seems to make a lot of logical sense to me. What's going on here? Mapping the continents. Countries, oceans, and rivers present a continuing challenge. Just as important is knowing where places are in the world and understanding their relationship to one another, which is incredibly important, in my opinion. As the National Geographic Society celebrates its centennial and prepares to move into the 21st century, President Gilbert M. Grosvenor is committing substantial resources to help restore geography education to United States classrooms. Maps and globes are crucial to this effort. The new world map, used in conjunction with the Society's education programs, we believe, serve as a valuable resource for members, teachers, and students alike. Arthur Robinson's projection strongly suggests the roundness of the Earth. We hope that its main legacy will be a generation of map readers more critical of flat maps, all of which play tricks with the round shape of the world we inhabit. That's it. Over here, saluting the achievement of his former teacher, Chief Cartographer John Garver gives a National Geographic Centennial button to Arthur Robinson, who created his projection of the world in 1963. On behalf of the Society, Carver offered Robinson the title of Honorary Chief, recognizing his lifelong dedication to cartography. Alright, well, there's some reference for you guys. I'm not going to put too much of my own opinion on this one. Let you kind of run with it, maybe make some videos yourself talking about it. And you can certainly use any of my footage, and I don't care if you give me credit, because I care about the ideas and I care about the understanding and the truth. And if they are lying, we need to kind of read through, because lies have holes, and there's holes in their story here. So, stories with holes, figure them out, break the code, and it's only meant for those to find out who want to find out. If you don't care, then you aren't here. If you do care about truth and nothing but the truth, then get it out there. Do what you can. Love you guys, namaste, and create your reality to be awesome.